Hi everyone, today we're going to look at draggable properties, or shall we say the ability to drag nodes, controls and anything that you can see in a scene graph in JavaFX. So this is quite a useful feature to have because some applications allow you to reposition the user interface, for example, and it's just nice to be able to drag things. It's just very user friendly from that perspective. So we're going to do just that in this video. Good news is it's actually very easy to do because JavaFX provides a lot of events that you can listen for and kind of use. So let's go for pane. That's typically a good parent to have because you don't want any layout. Since you're able to drag the nodes from one place to another, you don't really want a layout container that forces a specific layout. Let's have a circle. 25, shall we say? Yellow. A rectangle. Red. And something else. What other things do we have? We have a polygon. I don't want to use polygon though. Actually, that should do it. We might add something like a label. Yeah, let's do a non-geometric thing, so control. Something big, something readable. Circle, rectangle, and control. We want to probably position those. You can position an item using layout or translate. There are differences, but generally speaking, it doesn't really matter. It matters in some cases, but I won't mention those. They're very almost like edge cases when you're using both layout and translate in some form. Yeah, that'll do. All right, let's see what this looks like. Okay, yeah, that's fine. So the point is that we're going to add something to these things so that we can drag them in the scene graph. Let's make this a bit bigger. Now, what we want to be able to do is have a method that enables all of these things. So make draggable node, because node is the superclass of everything that you see in the scene graph, so we'll use that. Good news is this type, this supertype is enough, which means anything can be draggable. And then we can simply do something like this. Root get children for each node make draggable. And you can even use method reference here. Now onto the implementation. We probably want to have a separate class for this to store the offsets of each item. Okay, let's implement this the simplest way we can, and then we'll design around it if necessary. So if you want to make something draggable, you essentially need on mouse pressed so that you can capture the distance between the X and Y of the control and the point of the cursor. You then want to have a mouse dragged, I think that is it, so that you get events when the mouse or the cursor is being dragged over a node, which is what is going to happen when we try to drag a node. This is where you set the values, and this is where you calculate the kind of starting offset points. Let's go for something like this. Start Y. Get scene X, which will tell you the X value of the point of the cursor, essentially. We're going to offset that by the translate X, because that's what we're using to position our controls. So it's node get translate X. And we do the same for Y. And when we drag our mouse, we essentially do the opposite, because it's these two that we need to set. So we need to set its translate X, and we set it in exactly the same way as we've written in this equation, if you will, because we can take this and so imagine this is the thing that we need to calculate. What is this? Well, this is scene X minus start X, because start X is scene X minus translate X. So reasonably simple maths. In kind of a general form, it should look something like, I'll use A, B, and C. So we wanted to figure out what A was in this first case, so which is why we've written it this way. In the second case, we need to figure out what C is, given B and A. Well, it's just this, right? And the way to get there is A plus C equals B, so that we can move the C variable to the left-hand side, and then we need to move A to the right-hand side, giving us B minus A. And we do the same for the y-axis. Now let's try and run this. And now our node is movable. You can drag it around, you can position it as needed. You can also add an extra piece of functionality, something like snap to grid, because in various user interfaces, depending on what the user interface actually looks like, you may wish to have something like that, in which case you just take its translate X and Y and snap it to something that is close. Something like divisible by 5 maybe, or divisible by 2. I know, up to you, depending on how you want to build your user interface. And this is also draggable. I've used the same start X and start Y variables because they get reset when you click on something else. But you may wish to isolate this into a separate class if you wanted to. and this is also draggable. Since we're changing their translate X and Y, we're technically animating them. So you can play around with things like caching, which may improve performance, particularly if you're moving the text objects or any objects that have a font associated with them, some kind of font rendering. Anyway, that should give you an idea for how you can move things around in your JavaFX user interfaces. The most important points are, well, these are just normal stuff. So yeah, the entire logic is here. We're checking the distance between the 2 points. In set on mouse pressed, that's the event that occurs when the user presses on a node, which is the starting event of any dragging events. Because in order to drag something, a node, you need to click on it, or rather you need to press on it first, because click is different. Click is when you press and release. So you want set on mouse pressed rather than clicked. And then on mouse dragged is when you are still holding the button pressed and now you're moving the mouse. It's no longer mouse move event, it's mouse drag event, which is going to call this piece of code, which just inverts what we had here using reasonably simple maths. Okay, thanks for watching. I'll see you guys later.